Welcome, fellow explorers of AI magic. After all, isn't AI just our modern-day version of magic? Today I'm bringing you a tutorial on how to use artificial intelligence to analyze images. I'll guide you step by step on setting up your environment and writing programs from scratch. What's great is that you don't even need to pay for tokens to start coding AI solutions, so now you have no excuses. It's time to get started today. Since we will be programming in Python, as usual, we start by creating a virtual environment. We'll name it Vision. While the environment is being created, I'll just mention that a more complete explanation of why we are creating this environment can be found in earlier tutorials, particularly in the video about your first AI program in Python. And while we're on the channels page, please consider subscribing so you don't miss future content. Let's jump back into our virtual environment, which should be all set up by now. In the meantime, a folder has been created. Let's take a look inside. Yes, we have everything we need. We can now move on to Visual Studio Code, which we will use to create the program. In VS Code, I need to open the folder where my virtual environment is located in order to use it. As I've mentioned several times, secret API keys should be kept in environment variables. So first I'm going to create a .env file to store them securely. In today's lesson, we'll be working with 3 AI providers: OpenAI, Google, and Groq. So I'll need to set up 3 environment variables. When you create your program, you'll probably focus on just one provider, but I want to showcase all the options so you have a choice. Now I need to get all 3 API keys from their providers, starting with OpenAI. Just a heads up, with OpenAI you pay for the tokens you use. The costs aren't too high, and you'll get $18 worth of credits for testing initially. But remember, that's not the only option out there. On the platform OpenAI.com website, keys can be generated in this place. I have already generated mine and copied it to the clipboard, so I am just pasting it. If you're developing a program and want to avoid paying for tokens, you can use Google AI Studio. Google offers excellent Gemini LLMs and is currently providing free API keys for testing. Simply log into aistudiogoogle.com. Then click Get API Key and create API key. I copy the key to the clipboard and paste it into my .env file. Please remember that API keys are confidential, so mine will be deactivated before this video goes live. If you caught my last videos, you're definitely familiar with Groq. They provide access to open source models and offer developers free keys as part of their free tier. Simply log into their developer console. Then select API keys and create a key. Of course, the key needs to be named. I still have to confirm that I'm not a robot, which nowadays is not so obvious anymore. And there you have it. Completely free, with quite reasonable limits. Alright, the least enjoyable part is behind us. We have the API keys ready. Now we'll deal with the test images for analysis. I'm setting up a folder called Images to save my pictures. To have some material for testing, I've prepared 3 photos in advance, and I'll copy them to this folder now. I tried to make them varied, so that it would be possible to test the intelligence level of the models at the same time. The first image is just the title screen from one of my latest videos about a free voice keyboard that's completely changed how I use my computer. By the way, I highly recommend checking it out. Next we have a handwritten definite integral, which I hope our models will be able to calculate. And finally, a photo from one of my sailing trips. I think it's a pretty unique spot, so let's see if AI can figure out where it was taken. Alright, I think we can finally move on to the part everyone has been waiting for, which is programming. We'll start with OpenAI, and first I'll show that for simple applications no AI-related libraries are needed at all. The OpenAI API is quite simple, so we really only need the request library to perform standard HTTP requests. I created a Python file, so now I'm going to increase the font size to make it easier to read. Let's start with our environmental variables. Since I saved them in a .env file, they need to be loaded somehow. So I import the .env module. Since this is a fresh virtual environment, no modules are installed. Therefore, I need to install this package first. I use the pip install command for this as usual. I specifically need load_.env. I am also importing OS because I will need to retrieve the value of these environment variables. In the next step, I load the environment variables using the load.env function. Next, I create an API key variable to which I assign the value from my environment. In this example, we are working with OpenAI, so it is an OpenAI API. I also need to define the image, so I set up a variable called ImagePath for that purpose. Since I will be working with images that I have locally on my computer, not on a server, I can't provide their URL, so I need to encode them in base64 format. That's why I am importing the base64 module. Base64 lets you turn binary files into text strings that APIs can understand. It's a widely used encoding method. I'm creating a function that takes an image's file path as an argument and returns its base64 representation. I'm opening the file for binary reading because it is a binary file. I'm assigning it the variable image file. I'll hide the terminal to make the code more visible. Now I can read the contents of the file using the read method. I already have the file contents in the variable image data. Now I need to decode it. I use the B64 encode method for this, to which I provide my image data. And in this way, I get an array of bytes. However, I want to have a string, so I perform the decode method to the UTF-8 standard on it. This way, the variable encoded str contains my image in base64 format. This value still needs to be returned. Alright, let's now summarize what our program has done so far. Well, essentially it hasn't done anything. We've just loaded some variables, set a few values, and defined a function. Now, let's get to the first major task, loading an image and converting it into a base64 representation. So, I'm going to call our function encodeImage and pass our image path to it. Now I would like to start working on making API calls, but for that I will need the request library. Therefore, I will import it. It is not yet installed, so I also need to run the pip install command in the terminal. I must admit that the repository system in Python works great and installed, but I see that the editor shows me two syntax errors. Oh right, missing colons, a minor detail. I'll fix it quickly. I also see a typo that of course the editor couldn't catch. Now we can focus on connecting to the API. Since we are not using the OpenAI library, we need to handle authentication ourselves. Authentication using the API is usually very simple. We just need to include our key in the header, preceded by the keyword bearer. We also need to specify the format of the data we will be sending. In our case, it will simply be JSON. Therefore, I am including the appropriate content type header. Note that the variable headers is a dictionary. I will use it later when I call the API. For now, I still need the content of the call. So I'm defining the variable payload, also as a dictionary, although its structure will be more complex. First, the model. It will be GPT-4o, which is multimodal and can read images. Next, the most important thing in the world of communication with LLM. Messages. Messages are an array of dictionaries containing the conversation history. Therefore, each message contains a role and content. Our case is simple because we only have content from the user and do not anticipate a longer conversation. In our case, the content is also an array that will contain two elements. One will be related to text and one to our image. At the beginning, we need to set the type of the first element. It's text. Then the text itself. The first image is the title screen from the video about AI Voice Keyboard. Therefore, in the prompt, I am asking to list all the texts that are on the image and provide information if there is anything else there. I see that I forgot to add curly brackets, which denote a dictionary. When defining such complex structures, it's always easy to make a mistake. You should keep this in mind. We already have the text defined. Now it's time to focus on the second element, which is the image. Specifically, we define this as the image URL. Of course, in our case, it won't be a classic URL because we aren't hosting the image anywhere. But the content of the image can also be included in the URL, which is exactly why we encoded it to base 64. Of course, there is no point in memorizing this notation because you can always find it in the documentation. However, note that image URL is also a dictionary consisting of two elements. The first is, of course, the URL, while the second specifies the level of details. Let's take a moment to focus on this second parameter. To understand it better, we'll dive into the OpenAI documentation. Keep in mind that this explanation is specific to OpenAI's models, and different models might handle images a bit differently. However, this aspect also impacts operational cost, so we'll break it down in more detail. The parameter can take three values: low, high, or auto. This gives us control over how the model processes the image and how much we pay for it. But of course, it also affects how accurately it can be analyzed. If we specify a low number of details, the matter is simple. The model will receive a scaled version to 512 by 512 pixels, and we will pay for it as much as for 85 tokens. At high resolution, the model also receives a scaled version to 512 by 512, but also tiles of the same size that make up the entire image. For each such tile, we pay extra as much as for 170 tokens. The whole process is described well a little further down. The conclusion is that the model is not able to analyze very large images, so it doesn't make sense to send such images. But for now, let's get back to our code. The payload is basically already defined, but just in case, let's add a parameter specifying the maximum number of tokens to limit costs. Yes, this is the moment when we can send a request to the OpenAI API. Finally. We use the requests library for this, and the HTTP method is POST. The API URL is well known, but if necessary, it can be found in the documentation. We must, of course, include our payload as JSON, and headers that are responsible, among other things, for authentication. Before you display any content, it's a good idea to check the response status. After all, handling errors is crucial. According to protocol specifications, a successful HTTP request has a status code of 200. If it works, we'll need to write the contents of the response, keeping in mind that it's in JSON format. If you're wondering why this object is so complex, I recommend checking out the previous tutorial, where it's explained in detail. If, on the other hand, the call ended in failure, it's worth printing an error message. I think that's everything we need. The program isn't too complicated, right? Except for the payload object, which took us a bit to put together, it's pretty short and quick to write, even without using specialized libraries for API handling. I think it's time to start it and see if I made any mistakes. Failed to open the image file for reading. There is no such thing as images/AI-keyboard.jpg. Let's check if I made a mistake in the name. Of course, the hyphen is missing. I am correcting the name and restarting. Unexpected JSON payload argument. Okay, I think this argument was simply called JSON. Let's check. Oh, so many errors. It seems that there's something wrong with checking the response status. It was probably the status code, not simply status. Success? Finally. Yes, this is a very good response. Both the text has been correctly read and there is information about the microphone in the picture. So our program works and the artificial intelligence can interpret the image. As a reminder, free AI voice keyboard. Say goodbye to typing. and of course the microphone on the left side. We can probably conclude that this execution was a complete success, right? With the next picture, I feel like I should give you some background. I took this photo during one of my sailing trips. Perhaps the most important thing is that it's not a popular tourist destination with millions of photos online, but it is also not a place completely unknown to people. Off the coast of Africa, there's an amazing place known as the Canary Islands. But if we focus on the northern part, we'll discover a small archipelago. The largest of the Chinio archipelago islands is La Graciosa. You can get there by yacht, as I did, or by a small ferry from the neighboring island of Lanzarote. Staying in this small port, I decided to go to the volcano Montaña del Mojon in the morning. When I was up on the volcano, I used a telephoto lens to snap a photo facing north. So in my picture, you can see the cone of Montaña Bermeja. You can also see the Isla de Montaña Clara. This rock here is Roque del Oeste. In the distance, you can see Alegranza Island with the distinctive Caldera Blanca volcano. I'm mentioning this because I'd like to ask AI to identify which islands can be seen in the photo. This is Montaña Bermeja, so you can definitely say that La Graciosa is in the photo. Here is Isla de Montaña Clara, which is certainly an island. I don't know if Roque del Oeste counts as an island. However, Alegranza is definitely an island. Let's modify the program so that it recognizes these islands. Definitely, the file name needs to be changed, as well as the prompt. It's also worth mentioning that the photo file doesn't include any EXIF data, so location info isn't encoded in it. This isn't a big deal since the API doesn't use EXIF data and only transmits the image itself, but I removed it just to be sure. I request artificial intelligence to list islands, but I want to receive it in JSON format. Because when we use LLM in a program, we usually want formatting that is friendly for further processing. Let's see if AI knows these islands. No, it doesn't. But let's do one more test. Let's set the detail level to high. We'll see if it changes anything. Yes, absolutely, there is a difference. 3 islands were listed in JSON format. The only one missing here is La Graciosa, but let's assume that since I've been there, it could be understood that I don't mean it. However, there is Roque del Oeste, which I thought wouldn't be recognized as an island. So for me, it's definitely a pass. Let's focus on the last image. I think it is self-explanatory, and probably doesn't even need a prompt. It seems to me that artificial intelligence should understand on its own that the task is about calculating this definite integral. By the way, the expected result is 10. Let's change the file name and remove the text prompt. Okay, we can run the program. And here you go. The result is as expected. 10. Of course, I won't be checking the entire line of reasoning. But since the result turned out correct, I assume everything is fine. So definitely pass. Okay, it took a bit of time since we tested 3 different pictures, but we can consider the first program ready. Let's move on to the next stage. I'll be preparing a new program using OpenAI libraries, and for simplicity, I'll copy the existing program into a new file. I just realized I accidentally saved the files in the images subdirectory instead of the main project folder. I'll go ahead and move them to keep things organized. And this is fixed. Now we can focus on the program. I pasted the previous program into a new file. Now, we will go through it step by step and make the necessary changes. First, I import the OpenAI instead of requests library. As you can see, the syntax is not highlighting, which is the best sign that the library is not installed. So I am installing it with the pip install command. Looking at how many dependencies this library has, you probably already understand why it's sometimes better to use a simpler and lighter solution with the request library, especially when our program is really simple. Okay, installed. let's see what else we can simplify with this. I think we can safely remove the import of the OS module, since we don't need to manually fetch the API key. Authentication is handled by the OpenAI library, and it will retrieve it from the environment variables itself. The image encoding function remains as it is, but I can safely remove the reference to headers. But I need to additionally define the OpenAI client. Then I need to create a chat completion based on this. But the good news is that I will basically be able to reuse the payload, just in a slightly modified form. I need to convert the dictionary into function parameters. It shouldn't be too complicated. But before I take care of that, I will remove the rest of the code because it needs to be changed. Now I'm converting dictionary keys into function parameters. Notice that I don't even have to change their names. It remains to write out the result. This time, I will print a little more than just the content as before, but it should still be possible to read the result, only the object itself will be somewhat redundant. Let's see if I haven't made any mistakes and if the program will execute correctly. Yes, we have the result. Although it is a bit less readable because instead of new lines we have /n markers, but if we look at the final part, the integral is indeed calculated and we obtained the result of 10. But honestly, I wrote out a bit too little, because what I wanted to show is the number of tokens used. Therefore, I will expand this object a bit by printing out the entire response. Okay, that's exactly what I meant. The most important information here is that we use 262 prompt tokens by sending our query, the main part of which is the image. Let's now change the level of detail to low to check if the number of prompt tokens actually decreases. As you remember the earlier considerations regarding the use of tokens by images, you probably know that we expect something only slightly larger than 85. Yes, that's correct. Reducing the level of detail has resulted in the number of input tokens decreasing by roughly 3 times. We now have 92. By the way, notice that in this case, cutting down on the details didn't cause any issues with recognizing the image. The integral is calculated correctly and the result is 10. We can assume that the second program is working correctly, so let's move on to writing the third one. This time, we'll use the LangChain library. I'll try to reuse some existing code by copying the beginning of our file into the new program. However, I need to make some changes. First of all, I will remove the reference to the OpenAI library because it is no longer needed. Instead, I will install the LangChain core and LangChain OpenAI libraries. As always, I use pip install for this. As you can see, this library also has quite a few dependencies, but it is truly invaluable for more complex programs. You will see how it simplifies our code. If you want to learn more about LangChain, it's definitely worth looking at the earlier tutorials. However, let's focus on our program and move on to the imports. I will need 2 things. First, a human message to define our prompt, and second, the OpenAI chat class itself. First, I'm going to create an LLM by instantiating an object of this class. The model we're using here is GPT-4o, just like before. However, feel free to use a newer version if you'd like. Now I will define my query as an instance of the human message class. This time, I won't even define a text prompt, because we are working with an image that contains an integral, and the LLM can infer that it's about solving it. You've probably already noticed that the content definition scheme is very similar to the previous one. Therefore, to simplify things a bit, I'll copy the URL from the previous example. And pasted. Essentially, what remains is executing the invoke method and printing the result. Of course, for a complete picture, I would also encourage you to use output parsers, but in this case it doesn't matter at all. As you can see, printing the result is also easier. And that's basically everything. The program using LangChain is definitely shorter than the others, so I can try running it now. Not only did we get a result, but it's also spot on. So, I think it's safe to say that all three programs using OpenAI language models are working fine. Which version you pick really depends on what you prefer and need. If you're writing short, lightweight code, go without any libraries. But if you're planning something bigger that might need modifications or connections to another language model later, I'd suggest going with LangChain. Let's close this chapter and focus on the language model from Google, specifically Gemini. I created a new file, but I would like to obtain the program code from Google AI Studio. Using the Playground interface, I will prepare a query containing an image, but I will not execute it. The point is to get a sample code for my case, which I can then modify. I'm entering a text prompt to have everything complete. Now, pay attention to the magical Get Code button. It shows the code for this specific query. I copy it. I will paste this code into my file and then we will analyze it. Pasted. What initially stands out is that Base64 is imported but not used. What more, Google Gen AI is not installed in my environment. Additionally, I can see that the files array is not defined anywhere. As I browse through the rest of the code, I don't see anything else suspicious. Yes, it looks rather okay. First, I'll install any missing packages and then I'll handle the files. We don't need to worry about encoding images to Base64 because the Google library already provides that functionality. So, there isn't much that needs changing. Installing these libraries always takes some time because there are many dependencies and functionalities that we don't use for such simple examples. Alright, installed. I will correct the API key because my environment variable is called Google API key, not Gemini. I define files as an array. Inside, I place one file created by the upload method. It's a fairly simple construction, but maybe not so obvious. As you can see, the model used is Gemini 2.0 Flash. It's quite new, but not the strongest. However, it is fast. I'm taking a look to see if there's anything else we can simplify here. We could potentially change the response MIME types, but for now, I'm just going to remove 3 parameters that aren't really significant for us. I don't see anything else that would be worth changing. It seems to me that everything should be fine now. I will try to run this program. It's a small LLM, so it's quite fast. Unfortunately, I see some hallucination here. Roque del Este is definitely not visible in the photo. The model made a slight mistake, but the program works correctly. Let's try to write a similar program now, but using LangChain. I will take our last version prepared for OpenAI as a base, because it uses LangChain. That will be the easiest. I copied the content into a new file. This is the version that calculates the integral. Let's see what needs to be changed. I will definitely need a new library because we are no longer working with OpenAI. The chat model will also be different. Of course, the LangChain module for Google Gen AI is not installed, so I also need to add it. While the installation is running, let me share my thoughts on Google. If OpenAI doesn't specifically interest you and you're looking for something that isn't open source, then Google might be a great choice. They have some impressive models, and you can currently use their API key for free. Of course, there's also open source and Grok as alternative, but we'll dive into those shortly. Pip did an excellent job as usual, and the package is installed without a hitch. Now, I'm going to make a few more changes. I need to update the LLM to switch the chat functionality over to Google Generative AI. Obviously, the model can't be GPT-4o, since that's an OpenAI product. So instead, we'll go with Gemini 2.0 Flash. Surprisingly, that should be all we need. As you can see, Gemini Flash handled the integral perfectly. You have to admit, LangChain gives you the amazing benefit of making your program independent from the AI layer. This makes it super easy to switch out the underlying engine. And this doesn't just apply to the LLM. It applies to every implemented mechanism. Universality and flexibility are key here. Let's move on to our last provider, which is Grok. It's a great platform that offers open source models. And of course, free API keys for developers. Here, for a change, I will take our second program for OpenAI. I am copying it into my Python file grok-test1. Let's see what needs to be changed to use Grok models. These are definitely libraries. I need to import them and, of course, install them. The installation was very quick. Either this library is lighter, or the dependencies were already installed with OpenAI. I definitely need to change the client initialization from OpenAI to Grok as well. We will definitely not use the GPT-4o model, as it is typical for OpenAI. Instead, we can choose one of the open source models, such as Llama 90B, which supports vision. Let's consider for a moment whether anything else is worth changing here. In my opinion, the program looks rather okay. If anything, we can increase the number of tokens just in case, and only display the content of the message for greater clarity. Everything else, in my opinion, looks perfectly fine. Let's just run this program and see if it works correctly, and whether Llama can handle the integral. Grok is incredibly fast, which is their great advantage. And as you can see, Llama calculated the integral excellently. So we have complete success. And the program change wasn't too complicated, right? Let's now take care of the last case. Let's try to write a program for Grok using LangChain. However, I have some bad news. Let's take a moment to look at the documentation. This is the documentation for ChatGrok on the LangChain page. Honestly, I haven't verified this information, but according to the documentation, it clearly states that images as input are not accepted. We could check this experimentally, but I'll show you another way. Let's copy our last program for OpenAI and LangChain into a new file. I call it grok-test2, and I promise that this is the last program today. You need to know that Grok, like many other providers, boasts compatibility with the OpenAI API. OpenAI is, in a way, a standard in this world. So let's use our program, but change only parameters such as the model name, API endpoint, and of course, the key, which must be from Grok. You have to admit that this is also not a very complex change. Basically, you could say that the program remains exactly the same. Okay, I can already see that we'll need to change one more thing, because we are retrieving an environment variable, and we are not importing the OS module. The OS module needs to be simply imported, and nothing else. And here the integral was also calculated without any problem. This means that although the ChatGrok doesn't handle images, Grok through the OpenAI API has no issues with this. A bit strange, but it works. Alright, let's wrap up today's episode, which turned out to be quite lengthy. I hope we've thoroughly covered the topic, and you now realize just how many choices you have in this field. As a developer, you don't need to pay for tokens to experiment with LLMs, even for image analysis. This is a significant benefit. I particularly recommend checking out Grok, which offers open source models. It's also worth exploring models from Google, and if paying a small fee for tokens isn't a problem, OpenAI should definitely be on your list. You've got the technical details down, but if you're curious about practical applications, like in business or smart homes, leave a comment and let me know. It'll help me see if you want an episode on that. That's it for today. May your programs always be flawless. See you next time.